right, sometimes what we do is we complete operations. I have so many papers. We complete operations with our bounds. So our operations with this, a rectangular picture is to be framed in a glass and has a length of L, a width of W, respectively, these two numbers, correct to 0.1 centimeters, which means that this is your level of precision, okay? We're going to first find the bounds on our length and on our width. So our length, because it says length and width respectively, so that means that the first one is length and the second one is width. So if we rounded 64.3 to the 0.1 place, that means that we're going to do 0, if P is 0.1, then P over 2 is going to be 0.05. And I'm going to add and subtract that number to 64.3, or I'm going to think about it as 30 and do 35, and then 25. My width is 48.2, so we're going to do 48.2 lives between, either add and subtract, it's the same level of precision, so either add and subtract 0.5 or think about it as 20 and do 25 and 15. Okay, we're going to find the bound on the area. So we have a way to find the area, but that's not what it's asking. It's asking for the bound of the area. So how do we find area normally? Well, how we find area normally is length times width, okay? But we're not asking for the actual area, we're asking for the bounds. So what that means is that we need to get a minimum that the area could be and a maximum that the area could be. Well, the minimum area is just going to be the minimum of the length times the minimum of the width. And the maximum of the area is going to be the length maximum times the width maximum. So we take these bounds that we found up here and use them to then calculate the area. So that means I need to take these two numbers and multiply them together to get this lower bound. So when we're talking about just given a number and then find the bounds, all you have to do is find the bounds. But sometimes you're given numbers, more often than not, this is what you're going to be asked to do. You need to take those numbers and then use those numbers to create bounds for something else. So you're going to be using them with operations. This operation happens to be multiplication. Notice that example 5 is going to be division, and it works a little bit differently. But this one, if you want to get the most, you would take the two largest numbers and multiply them together. If you want to get the smallest, you would take the two smallest numbers and multiply them together. So multiplying these two together, I've already done it. So this is going to be 64.25 times 48.15, which is 3,093.6375. Notice it doesn't even ask us to calculate the area, and so we don't even need to. It's just asking us to calculate the bounds. And then we take our two maximums. So that's 35 times 48.25, which is 3,104.8875. And those are your bounds. It doesn't tell you how to round it, and there are differing opinions on how you should round it with bounds. And for you guys, it doesn't really matter. As long as you took the right numbers and multiplied them together, it doesn't matter really how you round here. It says compare the level of precision from A to that of the original levels of precision. So I want you to notice the range of numbers that we're talking about for our original measurements. For our original measurements, we are really only 0.1 away right? The distance between the minimum and the maximum are very, very close. If you were to subtract these two, it's 0.1. So that's a really small range for the exact number to be in. So your amount of error that you might encounter is really, really small. Versus when you go to the bounds here at the bottom after we finished all of this, notice that the difference between 93 and 104 is about 11, I think a little bit over 11. So that's a much larger range comparatively to what the range is up here. So there's much more opportunity for there to be error in this approximation that you have. So saying somewhere along here that the range of values that you have for area is much larger than the range of values that you have for the linear measurements. So range of values the range is. So range of values is much larger for area than it is for our linear measurements. Which means more room for error. So when you round numbers at the beginning and then use those rounded numbers further on in the problem, the more and more and more errors you could possibly encounter. So this might be connecting with some things that your teachers have told you in the past about avoiding rounding until the very end. If you've maybe heard that before, that your teacher maybe has told you in the past, don't round now, wait till the very, very end of the problem to round. And that's because if you round at the beginning, the more you use that rounded number, the more and more room for error and being slightly off you have. Okay. So the body mass index of an individual is used as an indicator of obesity and calculated using this formula, where the mass is in kilograms and the height is in meters. It says calculate the bounds of the BMI of a person who has a mass of this, correct to 1 kilogram, 0.1 kilogram, and a height of this to correct to 0.01 meters. Now notice that this says to calculate the bounds. It does not say calculate the BMI. It says calculate the bounds on the BMI, which means we aren't actually even using these numbers to go into this formula. What we first need to do is calculate bounds on mass and height. So notice that problem or example number 4 was really leading you to finding the bounds on the area, but it gave you a little helpful, like, we need to do this first before we can move on to the second part. Example number 5 does not break it down for you. So example number 5 just says, hey, you need to calculate the bounds. You need to realize that that means that you need to calculate the bounds on the original measurements first before you can even start calculating the bounds on our final thing. So first we need to calculate the bounds on our mass and the height. So the mass, M for mass, is 65.5. And our level of precision is 0.1, which means that P over 2 is 0.05. Or I think of this as 50. So I do 55 and I do 45. On our height, our level of precision is 0.01, which means that P over 2 is 0.005. So our height is 1.76. So you add and subtract 0.05, or I do 1.7, and then think of this as 60. So I do 65, 1.7, and then 60 minus 5 is going to be 55. Now that we have those numbers, we need to then calculate the bounds for our BMI and realize that with division, it's going to be opposite of what you did for multiplication. The idea is you want the largest possible number for your maximum of the BMI. You want the largest possible number that you could get from these numbers. And the thing is that once you start dividing, for instance, if I had a bound of 2 and 3 and then 4 and 5, if I started dividing these numbers out, if I did 3 divided by 5 to get my maximum, which is 0.6, versus 3 divided by 4, which is 0.75, even though these are both the maximums, if you have a larger denominator, your decimal is going to be smaller. So what you want for the maximum, BMI maximum, you want the largest number you can possibly get up top. So if that's mass, it needs to be the mass maximum. And you want the smallest possible number you can get on the bottom, because 0.6 is smaller than 0.75. So you want the smallest possible number you can get on the bottom, which is actually then the lower bound of your height. So you want the height minimum squared on the bottom. That is going to give you the largest possible number, because 3 divided by 5 does not give you the maximum, even though those are both the maximum of their ranges. 3 divided by 4 would give you the largest number. And so that way we need to get the largest number here and the smallest number here. In reverse, your BMI minimum needs to then have the smallest possible number up top. So you need to do the minimum of your mass divided by, and then the largest possible number in the denominator. So that would be your height maximum squared. So that means we're taking these numbers and plugging them into here. This I'm going to ask for you to finish on your own. And then when you come into class, we'll talk about it together and practice it. This trips some students up, so we'll make sure to get through it and make sure you understand. Good job today, and I'll see you when I see you.